This is 8.7. It's some special cases for factoring. So we're going to look at, first here, perfect square trinomial. It's the result of squaring a binomial. So a plus b times a plus b, or a plus b squared, is of the form a squared plus 2ab plus b squared. We talked about this earlier in multiplying these, that you square the first term. So in other words, on this x plus 4 squared, you'd square the x. You multiply these two together. That's your a and your b. There's your a, there's your b. That's 4x, and then double it. That's what the 2 is telling us to do up here. Gives us 8x, and then plus the b squared, or the 4 squared, which is 16. A difference of squares is of the form two perfect squares being subtracted. And they can be factored as a squared minus b squared equals a plus b times a minus b. And so we talked about multiplying these together. When they looked the same except for differed by a sign, the middle term would disappear. So if the x is our a and the 36 is our b, what we're going to do is take the square root of each piece, and that's going to be our a and our b. So square root of x squared is x, and square root of 36 is 6. So we have x plus 6, x minus 6. So taking the square root of each of those perfect squares. Difference of squares, it's all in the name. It's two perfect squares, and the difference is they're being subtracted. So a difference of two perfect squares is you'll see a minus sign in here, and then a perfect square on each side of that minus sign. And you can factor it by taking the square root of each piece and then writing it as a sum and then as a difference. Finally, factoring by grouping. When we were doing our x box, we were really factoring it by grouping. We were taking a quadratic trinomial and splitting it into 4 terms, right, from 3 to 4 terms, and then using that to find the greatest common factor of each row and each column. This is really the same idea. If there are 4 terms, we factor them separately in 2 pairs. You're going to look at the, and you may have to regroup them, but in this case, we're going to look at just these 2 and factor out the greatest common factor of those 2, which is x squared. Divide x cubed by x squared, and we get x. Divide 2x squared by x squared, and we get 2. And then we're going to look at just these 2 and factor out the GCF of those 2, which is 8, and we're left with x plus 2. And what you should notice is that we have a common factor in each one of these 2 terms here and here. And that common factor I've underlined as x plus 2. So we're going to write down our common factor x plus 2. And what's left over is the other factor, x squared plus 8. So that's factoring by grouping. So look at the first 2, find a GCF of those, and then the second 2, find a GCF of those. If you don't find a GCF in the first 2 or the second 2, you might need to rearrange them, write them in a different order. So we're going to factor these. These are all perfect square trinomials. Here's how I know that. The first term is a perfect square, last term is a perfect square, and the middle term is twice the square root of the last term, which is 8, times the square root of the first term, which is k, and that gives me the middle term, 16k. So you got to watch for that as well. So we've got 2 factors there, k plus 8 times k plus 8, or k plus 8 squared. So if you recognize it, perfect square trinomial makes it real easy to factor. It's like in the picture, we've just got a rectangle that has 2 side lengths that are the same, and therefore it is an actual square. So there it is. This one, notice the sign is different here. So same idea. Take the square root of the first term, which is w, the square root of the last term, which is 4, and we're going to have a minus sign in between because of the minus sign right here. Make sure that if you multiply 4 times w and then double it, you get the middle term, 8w, and we do. Next one here, square root of x squared is x. Square root of 36 is 6. We're going to use a minus sign because of the minus sign there. And then squared. Here, square root of 4x squared is 2x. Square root of 9 is 3. I'm going to square that and just double check. Those two multiplied together equals 6x. If I double that, I do get 12x. So those are perfect square trinomials. Notice they have 3 terms. First and last terms are perfect squares. If you multiply the two together and double it, you get the middle term. These are all differences of squares. You'll notice they each have just 2 terms separated by a minus sign. You take the square root of that term, which is x, square root of that term, which is 9. We write it as x minus 9, x plus 9. Right here, also both perfect squares separated by a minus sign. So we take the square root of the first term, which is 3x. The square root of the last term is 5. So 3x plus 5, 3x minus 5, and we are good to go. Y squared minus 49. Square root of y squared is y. Square root of 49 is 7. So y plus 7, y minus 7. Now, just a reminder here, if I multiply these out using the distributive property, y times y would be y squared, y times 7 would be negative 7y. 7 times y is positive 7y. 7 times negative 7 is negative 49. These two cancel out, leaving just y squared minus 49. This one right here, square root of 49c squared is 7c. Square root of 1 is 1. So we have 7c plus 1, 7c minus 1. All right, last sample here is the factoring by grouping. All right, this is the factor by grouping. Notice that there's 4 terms. That's the key to seeing that that's the method we need to use. What we're going to do is look at the first 2 terms, take out the greatest common factor of the first 2 terms, which is x squared in this case. Divide x squared into x to the third, we get x. 3x squared divided by x squared is 3. And then look at the second 2 terms. Greatest common factor of those 2 is 9. And I'm left with x plus 3 once again. So if I take out the greatest common factor, x plus 3, and then what's left over is x squared plus 9. The second one, once again, x squared is the GCF. We're left with x plus 7. This one has a little bit of a trick to it. Notice 2 minus signs here. We're going to pull out a negative 1. The reason I'm doing that is I want to end up with an x plus 7 here so that these two match, giving me a greatest common factor of x plus 7. What's left over is x squared minus 1. Now, back here, this was completely factored. This x squared plus 9 looks very close to what we were just doing with the difference of squares, but it is not a difference. It is an addition sign there. Here, notice we do have a difference of squares, so this can be taken a step further. So x squared minus 1 can be factored as x plus 1, x minus 1, and then we're done. If you'd like to, you could pause the video. I'm going to do the next 2. They follow kind of the same pattern as each one above, and you can check your work. So go ahead and pause the video now and try these 2 problems, and then check my work. So notice here I pulled out a negative 9. If you distribute here, it's a negative 9x, positive 36. I pulled out a negative 9 so that I'd end up with an x minus 4 to match the first x minus 4. Now with x minus 4 times x squared minus 9, the x squared minus 9 can be factored further. There's a difference of squares, x plus 3 times x minus 3. That's it. Go ahead and write your summaries as special cases of factoring.